Yes. So at least from now on, for sure, it's being recorded. Great. So this was just before that. So let me go back to the slide. So slightly detailed view of the evolution that has happened from the 3GPP point of view. So you can see that 3G had not yet finished its kind of evolutionary path, and well before 3G could just kind of finish all what it had to offer, we have 4G, and and the reason partly was because, and you'll see that in the next slide, the reason for kind of jumping somewhere at this time when HSPA had just come out to the market, we had LTE offerings as well, and that primarily happened because of something coming from a non-3GPP world, which is the CDMA-based operators wanted to have a 4G technology primarily because of competition from WiMAX, and that forced 3GPP to kind of roll out LTE into the market, even though the full HSPA plus evolution was still ongoing. So if left to themselves, I think the 3GPP community would have stayed on with the HSPA plus evolution, but it just so happened that they were kind of forced to move to LTE. So we still have some operators, and of course there's technology evolution happening in HSPA plus fronts while LTE rollout is happening. Okay, and that's in fact one of the reasons why the 3GPP gave the name of long-term evolution, which implies that of course there is going to be short-term evolutions happening on this, but the long-term evolution is really on this front, okay, which is the LTE and the LTE Advanced technologies that we are seeing right now. Okay. Now, what forced LTE into the market was primarily this. The 3GPP2 operators, examples could include, for example, Verizon, Sprint in the US. If you're looking for something from an Indian market perspective, you have operators like Tata and Reliance, who were originally the CDMA operators. Some of them went through IS-95 and some of them started with CDMA 2000. eVideo was one of the first mobile broadband technologies that we saw in the marketplace. Then could you please mute whoever has just joined? So eVideo, and what happened there was really no roadmap beyond eVideo, and that kind of forced sort of operators like Verizon and Sprint to look at alternatives. If you recollect, Sprint actually chose the WiMAX route, and on hindsight, it was not a very good choice because WiMAX did not take off, primarily because of the whole ecosystem not supporting WiMAX. But then Verizon pushed LTE into the marketplace, and so we had a very successful push by one of the operators who wanted to go away from the 3GPP2 route. 3GPP2 had a 4G offering called Ultra Mobile Broadband, which really did not see light of day at all. So it was basically a technology which was on paper for a variety of IPR related reasons. And so LTE was the technology of choice for operators like Verizon. And it so happens that even for operators like Sprint, they have moved now to LTE or either going to LTE Advanced. Okay, so that's the route that some of those operators who were originally so-called CDMA operators have taken now to kind of go to the 4G world. Of course, in India, many of the operators who are deploying IS-95, CDMA 2000, and eVideo actually went back to GSM, GPRS, and then probably are moving to some 3G service now. Okay? So that's the status. So all of them are moving towards the 3GPP camp, and this would give you an idea as to why LTE was kind of pitched into the market slightly ahead of time, primarily because of the kind of void left by an evolution for the 3GPP2 operators. So if you look at the various releases, if you're familiar with these releases, things started with release 99, um, and from then on it kind of has gone on to a variety of releases. And the first important release with respect to LTE is what we call R8, and R8 is first real release which contained the LTE specs and some of the first versions of this technology. So the first deployed versions, this is, I would say, the deployed version of this technology. So that came out based on release 8, and ever since that time we have had a continuous, kind of evolution on the LTE front. So you see, this is release 8. Got deployed, and now people are looking at release 9, which had minor enhancements to LTE, primarily more, I would say, on the non-air interface aspects. Release 10 was a major kind of upgrade, primarily what we call or what we might know in practice as LTE-Advanced, okay, with a lot of fancy MIMO features and some features like carrier aggregation which have taken off very strongly. So release 10 was primarily sort of pushed again, I would say, in the standardization, primarily because the ITU came up with this so-called 4G specs called IMT. Forget the exact name. Of course, now for 5G we have 2020. So we had the IMT specs, which basically would allow some technology to qualify as 4G candidate. Now, on hindsight, in practice, it was not so important. But at that time, around the 2008-2009 time frame, it was very important to kind of have this 4G title because WiMAX was still alive, and so LTE had to make sure that it got the right specs into the standards to kind of qualify itself as a 4G technology. Okay? So release 10 was a major upgrade to satisfy a lot of those IMT requirements, and primarily the ITU, as I said, I forget the name of that IMT version, which was important from that perspective. But some of them have really taken off in the marketplace. So a lot of the advanced world have deployed release 10 capable LTE networks, and features like carrier aggregation and some of the HETnet related stuff that you would see here. And slowly but surely we are seeing a lot more interest in multicast broadcast services. Of course, a lot of SON is happening in the background. So many such things have come to the marketplace. Okay, so we are truly in the LTE advanced world today, while we look at what's happening around us in the LTE space. Okay? So though release 10 was a major landmark point and primarily pushed by some ITE requirements, but that doesn't mean that we have stopped inventing. Release 11, release 12 have happened. Of course, products based on release 12, etc., might take some time to come to the market. Okay, and so what we might find is that you will find some very advanced economies. And typically, one example is in Korea, where a lot of the latest products get deployed. So you might find some release 11 features already being deployed there. Okay? So some markets you will find the most advanced technologies coming into the market, but not all markets would have these kinds of things happening as we speak. So release 11 still tends to be the sort of the top release right now, but I think from next year or so on we should see more of release 12 coming into the market, and release 13 work is ongoing in the standards, and so all that will bring in some features which people are proposing there. Okay, And I'll talk about some of these toward the end. This is just to showcase that LTE is not standing still. LTE versions are happening. Each version seems to be adding newer things, primarily driven by the operator community as well as to a certain extent by vendors and regulators. So I think many of the features are likely to get implemented. As I said, the only thing is, of course, there is a cost and sort of handsets issues are always there depending on how fast the handsets can get kind of cycle through will kind of drive this whole game of whether we can get the latest release. Release 12, as I said, some features starting to attract a lot of attention. I'll talk about this more towards the end. And just to point out that release 13 is also happening with a lot of interest in some unlicensed bands, interest in IoT machine type communication, etc., being some big items which are likely to impact some of the specifications there. Okay? Good. So having gone through some of this sort of looking at LTE at a high level, let's just quickly review what we have learned so far or what we've covered. So let me just go through some of the points. So cellular technology, which did not have a 4G evolution path, leading to quick adoption of LTE. This, as I said, was a major point for some of these things. So 3GPP2, CDMA technology, CDMA meaning CDMA, EVDO technologies did not have a roadmap. First 3GPP release to specify LTE was release 8. Release 8. Okay. And of course, we have continued to evolve HSPA with a lot of features. HSPA plus, there's dual carrier HSPA, MIMO is there in HSPA, carrier aggregation is there in HSPA. So many things coming to HSPA as well. So we had 2G to 3G evolution, and then we have had 3G to 4G. Of course, 2G to 3G, we moved primarily from a circuit switch with some packet switch to again the same sort of framework with circuit switch and packet switch, whereas 3G to 4G, we have completely cut down the circuit switch notion layer interface. Sorry, we've just gone on to packet switch. Okay. So 2G to 3G, the core network literally remained the same. It was primarily only an air interface evolution, whereas 3G to 4G has both an air interface plus a core network, which had that EPC. Okay. Question 4, planned release 13. We have LTE in unlicensed bands coming up. People might refer to LTE-U or license assisted access. Competing technology for 4G, of course, WiMAX was once considered a competitor, but practically WiMAX is dead, at least as far as mobile cellular is concerned. WiMAX is being tried out for other niche application. And did 3GPP2 come up with a 4G standard? Yes, they did, called Ultra Mobile Broadband. Did not take off for a variety of reasons. So that's a quick overview, and I think we can probably take a few questions now. If you don't mind, maybe you can write your questions in the chat window. I'll wait maybe for a couple of minutes and then I'll proceed. If there are any questions or comments, I'll just watch my chat window for a couple of minutes, and if you are interested in raising some points, feel free to do so. Okay, so there's a question from Poonam on what is SON. SON is what we call as a self-optimizing network idea. So self-optimizing network, which basically implies that you don't have to go through the hassle of manual configuration of a lot of these network elements. It could involve your for example, your base station's radio related parameters, handover related parameters, or it could involve some uh, giving an ID to your base station, finding the right backbone node to connect. So one of the important use cases for SON is a base station is able to identify its neighbors and help its mobiles in the handover process. So that's one of the more popular SON use cases. Any other questions or comments? Okay, so let's move ahead. Feel free to type in your questions on the chat window. Once in a while, I'll try and come and take a look at that. Okay. So the reason why people have gone for LTE technology is primarily because of the high data rate requirements, which means that there are some channel related problems which cause severe errors and so on. So the whole wideband CDMA system, which kind of was the bedrock for 3G, was not designed for such high rates, primarily single digit megabit per second, and even that was not realized. HSPA had to do almost a TDM kind of system to manage the high rates. Okay? So I would say high peak rates was one major reason for going to an OFDM based technology, because it can handle the problems of intersymbol interference. Then there are, of course, the wireless spectral efficiency related problems, which basically implies that you need to do more in the given bandwidth. So this is primarily better BPS per hertz. Okay. Uplink was non-orthogonal in CDMA primarily because CDMA would depend on very strict timing, basically make sure that your sync is perfect if you want to get orthogonal uplink, and that would be very difficult. So we lived with uplink interference problem in CDMA systems, whereas now we have this non-orthogonal kind of limitation on capacity, which we kind of lived with in CDMA. So what we are going to do in the next generation system is make the uplink in a cell completely orthogonal. So that's important for capacity. Okay. And we saw that towards EVDO and HSPA side, we saw that the scheduling has also become much more sophisticated. So the whole radio resource framework is all based on a scheduled framework where time and frequency kind of measures of channel are taken and then used by the base station, or whatever name you call it, node B or E node B, tries to kind of allocate resources on the fly on the orders of milliseconds and try and leverage some of the feedback information. And as I mentioned in the differences between the 2G, 3G and 4G world, we have separate CS and PS core in 2G and 3G, and that had various issues with respect to scaling, handling voice and data, and so on. There was a question in the chat window while I was kind of going through this, is intersymbol interference and how high data rates cost them. So I'll address that question as we go along more towards the air interface technology side. So peak data rate wise, this is release 8 numbers. So release 8 numbers basically kind of targeted downlink speeds of 100 Mbps, uplink speeds of 50 Mbps. And if you really look at the standards, they do much better than these targets. So in that sense, they beat the requirements that we set out to achieve in the R8 standardization. Spectral efficiency, of course, always important for wireless. And so we have kind of targets of 3 to 4 times on the downlink, 2 to 3 times on the uplink compared to the closest release of 3G at that time, which was release 6. The bandwidth is an interesting thing because this is the first time in the whole 3GPP context that we had what is called as a scalable bandwidth, which means that the channel bandwidths or the channel spacings were not fixed. They could be as small as 1.4 megahertz and as big as 20 megahertz. This is all release 8. This is all single carrier bandwidth / channel spacing. Okay? So unlike the 2G 200 kilohertz or the 3G 5 megahertz, we now had bandwidths of the orders of starting with 1.4 all the way to 20 megahertz. Okay? And one of the reasons for accommodating smaller bandwidth was primarily because, and this is happening as we speak, is many of those cellular operators are tearing down their 2G networks and want to kind of put the 4G networks in their place, and so wherever convenient, this gives us some their 2G networks and want to kind of put the 4G networks in there. Sorry for the echo there. So the whole idea is that we now have small bandwidths, and so again request you to mute your lines if you haven't muted. Okay, so we have small bandwidths, at large bandwidths of course we have discrete steps, 1.3, 5, 10, etc. all the way to 20. So we have small bandwidths, large bandwidths, of course we have discrete steps. Again request you, Gurjot, please mute your line. Another important facet of LTE would be that in most cellular deployments till date had been only FDD. And towards the end of 3G's lifetime, we had some TDD action primarily from China. And so to avoid all the complications that arrived in 3G, we now have standardization taking care of these things right from the start. So we have a TDD version closely aligned to the FDD version with some minor differences. And I'll talk about a few TDD related things. Majority of deployed networks, I read last count that 80% of LTE is still FDD, but there is some, 15-20% seemingly TDD, and there's also scope for some more TDD coming up as we go ahead. Apart from the rates, we also have latency related numbers. So there is user plane latency, which kind of gives a nice feel for the user. The control plane latency, which helps as people kind of come in and go out of the network. So quick look at the network itself. So we have eNodeBs, which are the base stations. Of course, there's a terminal, UE, and there's the air interface, which is based on all the OFDM, MIMO, etc. And we have an interface connecting the two base stations. Often I get questions about is this a direct line? No, need not be a direct line. It just only shows a logical path. Of course, X2's application protocol is defined, X2's networking protocol is defined. So it's a whole format for carrying messages across base stations. How it is physically carried would be left to each operator's implementation. Okay? So just because there's a line connecting two base stations doesn't mean that there's a wire running between two base stations all the time. Okay? And connecting the eNodeBs to the core network is what we call as the EPC, so Evolved Packet Core. So the packet core has two separate paths. One path for carrying what we call as user plane, so you will see S1U here, and another path for carrying control plane data called S1MME, or sometimes called S1C. Okay. And so there's a clear separation of the control plane and user plane nodes, separation of the paths, and we'll see how that becomes handy, or why a decision like that was made as compared to some previous generations. Okay? So S-Gateway is more of a router type of platform which handles the user plane traffic and keeps track of the mobility of the EU TRAN world. P-Gateway is the external facing node, primarily interfacing with the internet and other services that the operator might offer. In many cases, the S-Gateway and the P-Gateway are basically co-located. So typically many operators have what we call as an SP gateway implementation. The reason why there's an interface defined is more useful when you have a roaming kind of scenario where the P gateway might be somewhere else, in which case then you have this interface defining from an S gateway to P gateway. Okay. MME typically, as I mentioned, is a control plane node which also talks to the subscriber system for authentication and some other nodes, primarily with record of service profiles of users. So these become very useful as the user enters the network or maybe roams to a network. The MME's job would be to authenticate. So by the way, MME has been answered in the chats. Mobility management entity, basically a control plane node which kind of manages all the authentication and also some of the states like going into idle mode and also tracking location in idle mode, etc. Okay. S gateway and P gateway are kind of the nodes which carry the data, which means that it's primarily coming into play during the sort of active states of the mobile, whereas MME comes into play even when the mobile is up and running, I mean just coming on, and also when it's in idle mode. Okay. Of course, there are other nodes in the EPC which policy and charging rules function plays a part in all the subscriber kind of profiling and what services and so on can be allowed for a subscriber. Okay. And of course, the P gateway is probably one of the most important nodes with respect to the applications and the sort of treatment somebody is going to get in the LTE network, because it's going to be sort of a gatekeeper for traffic going in and out of that network. And so questions about how many MMEs. There can be multiple MMEs for a single operator, and there can be a variety of reasons why that multiple MME strategy might be useful. Primarily, multiple MMEs could help you load balance. So in case there can be some load balance here. There could be, for example, RAN sharing. So there could be two service providers. This could be SP1, this could be SP2. So there is an between E node B talking to multiple MMEs based on kind of the service profile of the user. So there could be a RAN provider talking to multiple service providers basically. So for supporting many such concepts, one is a single service provider load balancing, and another is basically a idea of multiple service providers talking to a single RAN. And as has been remarked, so this is why this idea of an MME pool is there. Okay, which can be used for load balancing redundancy, as been said in the chats. Okay, so looking at the differences from the 4G and the 3G networks, of course, the 4G network is a very simple, sort of nice and clean picture, as you can see on the right here, as compared to a slightly more cluttered picture, I would say, for the 3G network on the left. So clearly, we don't have anything other than E node P for EU-TRAN. So all radio resource management, RRM, RRC, uh, all the handover signaling, everything is taken care by E node B. E node Bs can communicate with one another using this logical path called X2. Okay. E node Bs have clearly nodes which they talk to uh, for control and user plane purposes. User plane goes to S gateway, control plane goes to MME. Everything happens with an IP networking framework, which means that every active mobile in an LTE network has to have an IP address. Every node has an IP address, and so whatever you're talking about is all IP communication going through potentially either a public network like an internet, or it could be some kind of a private network which the operator maintains. Okay? So these are just logical paths which are shown between the E node B and S gateway. The physical paths are determined by the deployment scenarios that each operator face in different locations. And if you, for comparison, if you look at the 3G and 2G to your left, you can see that 3G specifically here because of the use of RNC. So RNCs are the ones which control most of the radio related matters. So you basically have a hierarchy where the node B actually depends on the RNCs, and of course then the packet data goes through SGSN and the circuit switch data go through MSC. Okay. So more nodes to maintain, data control mixing up, all that are potential problems. So the reason for doing that was primarily voice was a traffic which was where we started this mobile business, and to basically the voice solution was engineered with the circuit switch framework in mind, and so that's why you need to keep the circuit switch framework. And but for efficient data access you need a packet switch framework, and so you have a patchwork and PS and CS in the same sort of technology. LTE kind of thinks afresh. It only thinks packet switch PS. So no CS. So what about services like voice? They will also go through the PS route. So that's a fundamental framework difference. So that's why it's taken some time for LTE or what we call as the VoLTE service to really take off, primarily because it's quite different from how we did voice over 3G or 2G. 2G and 3G voice literally, as far as apart from air interface related differences, go through the same sort of framework. Whereas in the case of LTE, we not only have air interface differences, but we also have major differences in how we are carrying voice, because we are now carrying it as VoIP rather than circuit switch voice. Okay, so that's why VoLTE has taken some time, but I think in the last year, I think we have seen some traction, and I think momentum for VoLTE looks good as we move along. And as with any new technology, we have basically backward compatibility issues with previous generation. Of course, being from 3GPP, there's always very smooth interaction with both 3G and 2G, and handovers happen between the 4G, 3G, 2G worlds smoothly. Neighbors are identified, and all those things happen just like how we do an intra-system handover. So all those have been operational and working fine. In fact, right from day one, 3GPP2 handover is also happening, primarily because a lot of CDMA operators were one of the major customers of LTE. Okay. Today we are talking a lot about WLAN handing over smoothly to LTE and vice versa, and also a much more stronger interaction with Wi-Fi. I think these are things which are going to grow. And instead of just thinking handover, people are thinking of a lot of interesting strategies. So some of the things that we are talking about in release 13 is now that the mobile phone has both Wi-Fi and LTE, can we aggregate both of them and kind of pass on the benefits? So can these go on simultaneously over the air so that the user data can come down through two channels, one through a Wi-Fi channel and another through an LTE channel, so the user's perception of service in terms of data rate grows. Okay? So these are some things which have been talked about in some of the advanced standards. Spectrum wise, this is probably the only glitch in the whole LTE kind of framework, that we don't have harmonized spectrum across the globe. I don't think it's so much a showstopper now. There are lots of promising deployments in the lower frequency bands. In fact, a lot of North American interest, major operators started there, and I think continues to happen. A lot of changes there. This happens to be, I think, one of the more dominant bands now. And of course, in many Asian countries, including India, for example, we have used some of these bands to start deploying LTE. Original deployments were planned for WiMAX in this bands in many countries, including India. So you will see a lot of TD-LTE in some of these bands. And a lot of course, you need to watch the devices world. I think these bands are generally getting supported by devices. Region-wise, of course, you will see a lot of operators in North America using lower frequencies. So everybody seems to have at least some of the 700 and 800 in their mix, okay? And a lot more FDD, as you can see. There are few TED flavors coming up. That's a reforming of WiMAX. Europe, I think a lot more has happened. I've probably not captured it as much, I should have said. I think a lot of countries starting, deploying LTE now. And of course, the largest growth seems to be in Asia, where, with China is probably dominating started with 2500, but I think newer bands are coming up there. So China is the biggest growth market for LTE as we speak. And of course, you can see that the mobiles have also kind of latched on to this evolution. There are categories of mobiles. We have release 8, release 9 categories. We have release 10. We have released 11 categories. In fact, we have released 12. Release 12, in fact, has gone on to different frameworks for talking about UE categories because of the fact that too many features are there. And so how to kind of convey that information. Release 12 has a very different framework than just categories. Okay? So the categories give you an idea of what kind of peak rate supports the mobile support, what kind of modulation types on the uplink, downlink, and some of the MIMO related configurations that the mobile support. So let's review some of the points and maybe also listen into some chat questions. So let's take a look at that. So the only entity in the LTE RAM from the network point of view is the P, and that way there is no RMC kind of entity. Of course, in the older generation we had the PSC, so none of those entities are there. Core network advancements, basically clear separation of C plane and user plane, and no CSPS mixing, no CSPS, only all PS. Common bandwidth of deployment, generally not necessary. You can get a variety of deployments. There are people who have deployed 20 megahertz. Typically TDD guys have started with 20 megahertz. A lot of the FDD guys have been 2x10. Some operators even have done 2x5. So you'll find a variety of configs. The nice thing is right from day one, LTE UEs are geared to operate with different sort of bandwidths in different regions of the world. So it's a scalable bandwidth solution, so which means that you don't have a fixed bandwidth. Okay. And some advantages, the lower bandwidths allow you to reform spectrum. Performance parameters wise, we have latency, user plane and control plane. And the nodes through which the user traffic goes through is E node P, S gateway, and the P gateway. Typically it's the same box unless you're in a roaming kind of scenario. Okay. Let's take some questions. Let's see some questions. I think some of you have talked about enemies. There was a question earlier about how high data rates cause inter-symbol interference. So as you increase data rates, so what happens is the channel has what is called as a multi-path delay spread. So the delay spread is the orders, let's say for example, a typical outdoor cellular case, it could be a few microseconds. Let's say it's about 1 microsecond delay spread. Now when you have such a delay spread, what happens is that as you increase data rates, basically as your symbol time becomes comparable to this microsecond time, you start getting significant overlap of symbols, and that's what causes inter-symbol interference. Okay? So it's primarily delay spread and your data rate. So you can have a delay spread channel. So over a 1 microsecond channel, if you send a symbol time of 1 millisecond, which corresponds to 1 kilosymbols per second, you would not have any delays, any ISI to worry about. But on the same channel, if you start sending a 1 mega symbols per second, then you're starting to have some inter-symbol interference, because now the symbol duration is now comparable to the delay. That's why when you go to 100 megasymbols per second or 50 megasymbols per second, you're obviously going to get more inter-symbol interference. That's the connection between high data rate and inter-symbol interference. Any other questions or comments that you might have? Okay, so feel free to type in your questions and we'll take it at the next sort of logical point in the discussion. Okay. Yeah, so there's a question from Abbas, 2 cross 10. Yes, the question 2 cross 10 basically refers to an FTD allocation. Yes, one for uplink and the other for downlink. Yes, correct. But now remember that with carrier aggregation, we are having lots of combination. People are talking about carrier aggregation, which is going to be 10 plus 5 on the downlink, 10 on the uplink. So many such combinations are coming out. Good. So let's move ahead and then keep your questions coming. So let's look at technology now. So we talked about scalable OFDMA. That's happening here. Okay. And OFDM technology gives you a lot of interesting advantages with respect to high bitrate communication. And so we use on the downlink something called as OFDMA, which is a fancy FDMA plus TDMA. And on the uplink, we use a modified version of OFDMA called SC-FDMA or DFT spread FDMA, whichever you want to call. Okay. Slightly because it's more power efficient, that's all. So slightly better power efficiency, okay, as compared to plain vanilla OFDMA. Right from day one, LTE requires multiple antenna support. So which means that every LTE terminal on in the market has at least 2 antennas, at least using it for the receive. Some might use it even for transport. And of course, MIMO helps us get better spectral efficiencies, which is very important for any public wireless technologies. OFDMA helps us manage the spectrum very nicely because it can allocate in time and frequency to achieve certain end goals. Scheduling, very quick turnaround times, primarily to meet certain latency targets, to make sure that we have quick turnaround to give the user the perception of very fast service. A lot of radio feedback going into scheduling, all retransmissions handled at the node B, and so we have things like hybrid ARQ, which is very important for getting the correction done in the over the air related errors. So high data rates, of course, we throw more bandwidth. In fact, though I've talked about up to 20 megahertz, release 10 and beyond can allow you up to 100 megahertz of bandwidth. So that's one way to get higher peak rates. Multiple antennas give you higher spectral efficiencies and ergo get you better data rates. Of course, modulation techniques, we are up to 256, 64 QAM now. We are talking of 256 QAM in release 12, okay, and maybe more later. Okay. A quick question about hybrid ARQ. So hybrid ARQ is a retransmission technique primarily used, so whenever you have a base station and a mobile terminal, it doesn't matter which side it is, whenever you send data, there's a quick ACNAC which comes from the other side within a millisecond time. And so this hybrid ARQ basically allows you to correct for any errors in a very fast turnaround time, which is one facet of it. The other facet of this is that you also have this so-called incremental redundancy, okay, which means that you don't throw away the previous transmission. You add redundancy over on top of what you've already done, and then you give better chance for the combined transmission to get decoded. Okay? So it's basically, instead of wasting a lot of bits first time for redundancy, you throw some redundancy, and then if you get a NAC, you add some extra redundancy, which combined with the previous redundancy would give you a better chance for detecting your bits. Okay? So that's what hybrid ARQ is all about. Okay? Fast turnaround in terms of ACKs and NACs, millisecond time frame, and the ability to combine the previous transmission with the new redundancy to give you a potentially better chance of decoding bits. Okay. So comparisons with 2G, 3G, no BSC RNC, so no choke points, clear separation of control and user planes, so you can scope your boxes, whether it's a control plane processing node or a user plane processing node, and accordingly kind of build that node, maybe choose platforms, etc. Okay. Also delays, etc. User plane, control plane don't get mixed up, okay, at least on the backbone. IP-based core, so we can use a lot of IP networking that's out there. So there's no special networking layer defined. It's all going to use an IP address framework. As I said, LTE is an all IP kind of technology, which means that mobiles require IP address to function. Every node that you come across in LTE, basically the communication is all through an IP framework at the networking layer. And no CS services, when I mean that no CS kind of framework, of course we will support things like voice primarily as a VoIP service. So voice can go through in a couple of ways. One is something called as a circuit switch fallback, and primarily this is what has been happening so far in most of the deployments of LTE till recently, where because there is a legacy network, circuit switch network, all the LTE user does is drop their LTE connection and offload voice to 2G, 3G. Okay? It's understood that that was a temporary fix, but works very well. And the reason was VoLTE needed a little bit more kind of work behind the scenes, because one thing is VoLTE requires this IMS infrastructure, which needs to be deployed by the operators, okay, and support in the handsets. So all this required that VoLTE kind of will take its time, and I think we are just seeing the cusp of it now, where we are seeing handsets supporting VoLTE, operators slowly but surely getting on to IMS, and I think this is the starting point for the whole voice over IP supported by carriers coming to the cellular market. Okay, but I think we are clearly seeing a trend where the developed world is adopting this, tearing down their legacy 2G voice, and I don't know what they're doing with the 3G voice. Okay, but definitely they're tearing down their 2G networks, and I think clear move towards VoLTE is there. TD-LTE, as I mentioned, has a very specific framework where it's very successful, primarily in the data related framework with asymmetric traffic. Okay, originally thought that most of the traffic would be of asymmetric nature, but a lot of deployments have been FDD deployments. Okay, and you can see these are some uplink downlink configurations defined by the standard. In practice, most of the configurations which are popular are downlink heavy configurations. So wherever you see some of these bars being much taller, these are configurations which are popular in the market. Not all of them, but at least some of them. We still haven't found use cases for these as of now in practice, but I think it's just a matter of time. People have come up with some machine type applications with video coming in from users. All that might drive those uplink heavy configurations. And if you look at the 3G, HSPA plus and LTE, HSPA plus is what we call as more of an evolutionary approach, primarily with a lot of emphasis on backward compatibility, of course having some sort of restrictions on the bandwidth. So within that framework, HSPA, HSPA plus have tried to evolve, but everybody understands that that evolution is more of a short-term evolution. The real long-term evolution from a 4G point of view is all LTE, where air interface is completely new, much more scope for peak data rates, a lot of flexibility in bandwidth, brand new technology capable of handling the challenges due to high rate transmissions. And if we are not just satisfied with plain LTE, as I mentioned, LTE Advanced was quickly pitched into the market, primarily because, as I mentioned, there were some teething problems with respect to LTE Release 8 meeting certain IMT requirements. In fact, it's called IMT Advanced requirements. So this was the 4G title that was at stake between WiMAX, which was still alive, and LTE. LTE Release 8 did not meet some requirements of IMT Advanced, so Release 10 was standardized primarily to meet some of these requirements. So one of the important technologies which has been kind of taken up by operators in a big way is carrier aggregation. So carrier aggregation allows you to use multiple carriers, could be of different bandwidth, could be in different bands, and bundle them together and schedule them together so that you get the advantages of not just a combined big bandwidth, but also the fact that you can schedule in them together. So you also have the trunking efficiency. So apart from the bigger bandwidth, you also get the flexibility of being able to schedule over a bigger bandwidth. And so there's a lot of take for this interband, and of course now intra and interband aggregation is happening because as people reform spectrum, they can use that spectrum along with the LTE spectrum together and they can have carrier aggregation. So I think this is a key technology going forward. Okay. Already in deployment, handsets are supporting it. So there's a lot of scope for carrier aggregation. MIMO, though it's there from day one, probably not as significant in terms of the impact that it has made. But people are looking at alternatives to traditional MIMO. One of them is multi-user MIMO, which allows you to transmit on the same time frequency resources to more than one user. But there's also something similar to a soft handover scenario called COM. It's similar to a soft handover kind of scenario. Okay. So these are some MIMO advancements. There is looking like more potential in things like COM than in the plain vanilla MIMO, etc. Okay? And especially in small cell segment, you can see more of this. And coming to small scale, that's where this word headnets makes a lot of difference. Headnets are basically heterogeneous networks, primarily addressing certain capacity and hotspot related issues. So sometimes you often hear the term called small cells, very closely aligned with SetNet. So the main reason why the standards come into play is primarily to handle certain interference issues in the small cell context. And of course, as with any LTE or TGPP technology, backward compatibility with the earlier releases was considered to be very important. And of course, the most important small cell is what we call as a pico cell. And that's where a lot of action from operators. Again, probably has not taken off as much as what operators expected. There's a lot of competition from technologies like Wi-Fi. Some operators have gone more towards Wi-Fi. Some operators to this. There's also unlicensed band small cells coming up. So we'll find a lot of action in this area. There was some traction for this. The earlier word for this home UNOD was called as femtocell. You might have heard that in that context. A lot of interest in the home UNOD or femtocell market. Probably again with Wi-Fi adoption being very strong, the market for femto has not taken off as much. And relays are basically repeater-like things which primarily come into play in certain contexts where you don't want to deploy a full-fledged base station. You just want to provide some solution for a coverage of both. Okay? So I think these are some of the things that the headnets try to address, especially some of the capacity-related challenges in hotspots is what I think is attracting a lot of attention. So let's kind of slowly wrap up what we've learned. So let's look at it. So let's just look at these things. So, so I have release 5 all the way down to 15 lets me match. So I've got LTE bandwidth is easy for me. Uh, in LTE Advanced came first in release 10. SCFDMA is primarily for uplink. OFDMA is downlink. Release 5 introduces HSPA. Release 6 got HSUPA. So together we call it as HSPA. So let's look at some more questions here. Important radio related features in LTE Advanced. I would say the number one is the carrier aggregation, both inter and intra band. Very important features because operators have spectrum in different parts. They want to bundle and view them together. They want to use them more efficiently. Okay, so this way it's kind of extremely important to have this ability to aggregate, and also we have the ability to the handsets supporting this two band aggregation or the two carrier aggregation is already very popular. Three carrier aggregation is coming up. So I would say the number one technology. Next I would say is some of the things related to MIMO, especially the soft handover comp might make an impact. Still probably not such a strong thing. Carrier aggregation is on even right now. Which node is in charge of RRM in LTE? It's basically the E node B, which is in charge of all the radio tasks apart from the air interface related modulation coding MIMO. It also assigns resources in the OFDMA framework called resource blocks. Okay. So everything handover is handled by E node Bs. Okay. HetNet topologies planned in LTE is primarily the number one is the pico cell, which is the small cell topology, okay, which again the business has not taken off as much, and I think there's a lot of Wi-Fi which is competing. Home these have not really taken off in any big way. Again, I think Wi-Fi is making a big dent there. Relays are very kind of deployed primarily wherever you don't have too much of a, or you don't have a capacity problem, but you have a coverage problem. So TD-LTE, as I mentioned, has been taught along with FD-LTE from day one. So very few differences between FD and TD. One of them is the DL-UL split. Okay. So somebody has mentioned that femtocells or home node Bs are becoming prominent for some operators. I'm sure the operators will try to bring that in, but so far the trend that we have seen in the market is that uh, it has not taken off as much as what people anticipated. I mean, I don't see, for example, home node Bs being pushed into literally every user's house unless there's a compelling need. For example, in markets like India, where we don't have any reliable broadband coming into a significant percentage of homes, the only place where home Bs can make a small sort of impact could be, for example, using 4G itself as a backhaul technology. But that to me looks more like what we call as a MiFi solution rather than a home B solution. Okay. Uh, whole point is that if you had a reliable broadband, then the idea would be we would probably go for a Wi-Fi connection because a lot more devices support Wi-Fi than LTE. For example, you take your tablets, you take your laptops, all those things typically support Wi-Fi natively. However, the only devices which typically support the LTE kind of air interfaces are typically the phones. Okay? So that's why I think Wi-Fi has a slight lead whenever it comes to those devices. Doesn't mean that LTE loses, because we could still have a MiFi device which has LTE backhaul and Wi-Fi for access within the home or small office. Okay? There are configs. So I showed you a picture of the config. There are 7 configs, some of which are kind of being used right now. Peak rates, definitely OFDMA is contributing to that, bandwidth is contributing to that, and then of course we have MIMO contributing to that, modulation contributing to that. So many of these things contribute to the peak rates. Voice till recently was mostly circuit switch fallback, but slowly we are seeing a migration to VoLTE, and that's a trend. I think operators like Reliance Jio right from day one would want to do voice over LTE, okay, because they might not want to kind of fall back because they don't have too much of the legacy technology directly. They will have to partner with somebody. Good. So with that overview, we can now finally, as I mentioned, we can look at trends which are happening in the 5G camp. So people are already attempting, gigabit kind of rates, at least in the peak speeds, very low latencies for certain applications. Uh, as usual, lots of bandwidth, but then not just looking at link speeds, but also looking at reuse. Okay? Lot of emphasis with this green energy consumption, uh, cellular first, years of battery devices, lots of connected devices, especially in this IoT context. Okay. Low data rates, but lots of devices. We are also going to see a lot more, I think, mixing between the LTE and Wi-Fi camp. So we already have things like Wi-Fi calling happening, voice over Wi-Fi. We are having LTE Wi-Fi aggregation. So all these things are happening because the smartphone also has Wi-Fi, and so it means that now you can think of using both of them together rather than just using. There's also a camp on looking at LTE in the unlicensed band. Okay, so that's another trend. So many such things are coming together now. So I think they will all form important part of the mix as we look at future use of wireless. So with that, let me summarize. And LTE-EPC is the only 4G standard. It's got a lot of evolutions as we saw. OFDMA, MIMO, these are some key technologies, scheduling, differences with HSPA both in the air interface side as well as on the EPC or the core network side, and also what's coming up, not just in future release of LTE, maybe what we will see in 5G as well. Okay. So with that, just a show of the bands where band numbering, etc. You can see some of those numbers there. It's just for record. Anyway, you're going to have this presentation with you, so you can kind of take a look. Okay? So with that, I have finished my part of the presentation. So I'm open to taking any questions. I would still prefer if you can do that on a chat. So we can probably wait for some time. I hope the presentation was useful and satisfied your objective. So you can take some questions, comments, suggestions for any future seminars. So Naeem has asked this question about blind handover priority parameters. So in fact, unfortunately, I do not know much about that. So I can get back to you offline on this blind handover parameter setting. So sorry about that. I don't have an answer for that question. I'll get back to you. So question is voice quality better on VoLTE than CHFP? It's a little bit tricky question because the voice quality per se has nothing to do with the air interface. It all depends on how much bitrate we have provisioned for voice. I don't think per se VoLTE would have better voice quality than CSFP. If you have the right codecs on CSFP or on VoLTE, I don't think there's a big difference between these two. Okay? So the so-called HD voice can happen both over a CSFP network as well as a VoLTE network. But I think from a marketing point of view, somehow the HD voice is getting bundled with VoLTE. Question about delays and jitter in CS as compared to PS. I doubt whether if you engineer your CS networks properly, I don't see any reason why they would suffer any delay or jitter. In fact, PS has more scope for delay and jitter than CS because it's being a scheduled system as compared to a CS system where you basically allocate resources at the call setup time. So you should have less scope for any problems in CS as long as it's properly engineered end to end. PS is more challenging because PS needs to force that uh, delay jitter maintenance by proper scheduling on the air interface. Questions, comments? So I think very similar ideas, interfrequency, IRAT, cell reselection. So we do define neighbors from both the same technology and IRAT neighbors as well. Uh, so the priorities and there are thresholds defined, there are handover events defined for within LTE and between LTE and 3G and 2G. So it would depend on the deployment. Yeah. So there's a question about roaming. So when you talk about roaming across wide areas, not much difference from the network side. I mean, you basically have to kind of have permissions to roam across operators or across countries or geographic areas and kind of authenticate and move along the same way. Well, the frequency difference, you have to make sure that your equipment is able to support the frequency bands that are going to be operational in the roamed area. I think that is clearly, I take your point that it's not, there's a slight glitch there. So as long as your equipment is able to support, there should not be a problem. And with carrier aggregation framework now coming in, and if you take a look at the phones, at least the good ones, you will see the band support is quite big in terms of the coverage. Okay? So that's the only issue with LTE is the fact that the band is not uniform across the globe. But I think that's a small price to pay for all the other benefits. So ANR is basically, again, just like other technologies, the ANR is basically broadcast all the neighbors, and the SON can help the network figure out the neighbors and also discover neighbors and publicize. So there are messages called SIBs which go out regularly from the network side, which broadcasts information about neighbors, and these are expected to be known to the mobiles, and whenever they have to do some selection of neighbors, etc., they can basically send information. Regular reporting framework is all configured. And tracking area basically it's now all done by handled by the MME. So MME knows for an idle mode mobile where its tracking area is and so on. And so when a page comes to this mobile, the MME is the one which is actually pushing the eNode beast to page from the last tracking area that the UE has been seen under. Sure. ANR full form is automatic neighbor relations. Page cycle, remember that paging has a lot of parameters and one of them happens to be paging cycle. So the paging cycle will help the mobile know exactly when it has to read certain information, specifically potential pages that could come for this user. So in that sense, the paging cycle is important when the user is in idle mode. Any other questions or comments? Okay. If there are no questions, Sanjay, is this time we can close it? No, we don't have plans for doing anything else. We just thought of doing only LTE overview. We anticipated more questions, but that's okay. Sometimes, since the first time, we are also kind of doing this online.
Much, I think we can wrap up the session now.
Okay.
Right. I will be sharing the presentation as well as the recording with all of them.
Excellent.
Right. So if they have any other questions, they can also drop me an email also.
Excellent.
So I've already shared my email address.
Perfect.
Yeah.
So Sanjay will
Thank you very much.
keep you updated
That's
on
all.
future sessions. Yes. Okay.
Yeah.
Okay.
Thank you.
Yeah. Thanks all. We'll see you. Bye bye. Thank you.